In this video, I will now show you how to use a button to control the LED, and this project is to turn the LED on or off. So we will build a simple Arduino circuit, and we will later program and we can simulate to see how the button will control the on and off of this particular LED. And we can go to the component and we can type Arduino. So we have the component coming up, so you can double click to select the Arduino, and we can have a push button. So you can type push button, and when you click on this push button, you can also see the preview of this button. So we can double click to insert into our workspace, and we should have the resistor. So those are generic component, and we can have the LED, let's say red, and we can select the animated LED red. So I think those are the component that we need to build a simple Arduino and a push button. So you can place your Arduino here, and we can insert the button, and we can have the resistor. So to rotate, you can press the space key on your keyboard. By default, it can rotate the component. And we can have the LED connected to the pin 13. We have the resistor. Now we can do connection. It is connected to pin 13, and we can connect the ground. To zoom in, you can use the control, use your mouse by rolling away to zoom and rolling down to unzoom the workspace. And from there, we can be able to configure the resistor. Let's say let's give 220 R for 220 ohms. And our button, we can connect it to pin 2, and we have ground, and we can add a power supply to pin, so we can give plus 5 volts. So we have the 5 volts which is connected to a push button, and I can also explain. So we are going to program such that when the push button is pressed, this digital pin 2 will read as logic high, because we are now passing 5 volts to this particular pin. So when it reads that there is a 5 volts applied to this digital pin 2, now it will switch on the LED. That means it will be able to give out 5 volts at pin 13, and the 5 volts will pass through the resistor and the red LED. So this becomes a closed circuit. And this resistor is connected in such a way that when the push button is not pressed, now we can have this resistor act as a pull-up resistor. When we say pull-up resistor, that means it will make the pin 2 of the Arduino having a low state. And only when this button is pressed, then this will be giving the high state. However, when the button is not pressed, it will automatically enable pin 2 to be grounded. So that means it will be logic low at pin 2 when the button is not pressed. So this is called a pull-up resistor. So once the circuit is complete, we are now going to open up our Arduino IDE, or the development environment, and we can start to program. So I will explain the code as well. Like what I have explained, in order for this to operate, we now using a push button. So when the push button is pressed, that means the LED must go on. It's like a simple switch. When the button is not pressed, now the LED will be switched off. So this is a simple control logic for the digital system such as a microcontroller. So when the button is pressed, the LED will be on. When the button is released or not pressed, the LED won't light up. So it is something like a switch. If you switch on, then the light will be on. When you don't switch on, the light won't turn on. Now we can open up our new project. So by default, you have the void setup where you can put your code here to run only once, or if you want to run the code as in a loop, that means it will continue to run, then you will put it under the void loop. And now we can be able to program. So firstly, we have to initialize the pins. So we can say a constant integer for, let's say, button pin. And this button pin is assigned to pin 2. Or let me give you the side-by-side view. Okay, this is our side-by-side view. And we are using two peripherals or the component, such as the LED and the push button. So we will have to initialize. That means we are giving which pin or which particular peripherals the pin to operate, such as the push button. We initialize push button as an integer and it is connected to pin 2. And also we can give the constant integer value to the LED pin. And this LED pin is connected to pin 13 of our microcontroller. So firstly, we have to initialize the pin, and under void setup, we can now declare the pin as an input or the output. So we can see that the button pin, comma, and the button act as an input. Therefore, the microcontroller will now understand that the button pin is nothing but the input. That means the button will be available to receive the incoming signal, such as a binary 1 when the button is pressed or binary 0 when the button is not pressed. So we are now declaring those pins. So we declare that the LED pin, which is our output. That means this pin will be available to give out logic high or logic low. Logic high is corresponding to a 5 volts and logic low is correspond to a 0 volt. So we initialize the pin, we declare the pin as either a input pin or output pin. Now we come to the main section of the code. So unlike other syntax in the C language, we now should be able to use what is called the if-else statement. So if-else statement is a conditional statement where it will compare if something is true or not. So if the button is pressed, then it is true. If the button is not pressed, then it is false. So during the condition such that the button is pressed, what will happen? And if the button is not pressed, then what will happen? So we normally give the statement if, and now we have a digital read. So we can say digital read. Therefore, we are reading the pin. So which pin? And in this case, we are reading the button pin. So when you are reading a data, that means you should be reading a data from a specific pin. And since we initialize pin 2 as the button pin, if we wrote button pin here, it will automatically read the pin 2 because the pin 2 is nothing but it is the button pin. Therefore, when we say read to, if you don't put the button pin here, you can just simply write 2. That means the microcontroller will now read the data that is coming in as an input to pin 2. So let's say if the button at pin 2 is equals to, let's say, high, that means when we have 5 volts available at the pin 2, then it is a high. And when this is high, what will happen? So if this condition is true, we have to give a command such as digital write, and we have the LED pin must be high. That means when we say high, that means we are giving out 5 volts. So LED pin is nothing but we are writing a data such as a high, which is 5 volts. So we are writing data to the LED pin, and as we initialize, LED pin correspond to pin 13. So it will write a high, which is 5 volts at pin 13 if the button pin is high. That means if the input receive the signal that it is high, that means 5 volts is available when the button is pressed. Now this condition is true, so it will enable the LED to be switched on. Now we are writing AI, which will enable the LED to switch on. And the other condition else, if this condition is not true, if the button pin is 0, that means the input of the pin 2 is 0, then what will happen? Now we have to have a digital write. We will now write the pin at the LED pin, which must be low. So in that case, we are now writing data such as a logic 0. That means this pin 13 will give a logic low. And in that case, we can say that when the button is released. So when this condition is true, when the button pin reads a logic high, then we can be able to see that the LED is on if the button is pressed. And if this condition is not true, we can say LED off if button is not pressed. So these are the simple code that we can be able to analyze with the microcontroller circuit given. So you can save these documents. You can Control S, and we can go to the location where we store our circuit diagram. So let's say we have the circuit, so we can now have the code. So in this code, we can say our project, and we can save. So once it is saved, you now have to compile to see whether there are some errors. So when it is done compiling without the errors, you go to sketch and then you export compile binary, because when we have a real microcontroller hardware, then we can click the upload. We can verify and then upload. But since we already verified there is no error, we can now export the compile binary, because we only want this binary information that can be read by this Arduino microcontroller. So when it is done compiling the binary, we now click this one. We can go to the location where we have the code So this is our code. You can come to our project INO and it should be in hexadecimal. So we have program.ino.hexadecimal. So you select this one because this hexadecimal represents the binary information that we have. And once it is uploaded, you can click OK. So this code is now inside this chip. So we can click the run and we can be able to see the result. So we have them side by side. So now you can click the run button and we can see that there are no errors. So when we click the button, you can see the LED switch on. When you release the button, it will switch off. So this is a simple microcontroller circuit where we are using the push button to control the LED. So this is the hardware part and this is our software part. So the software is made up of a programmable or instruction code, and we have the hardware that execute the algorithm of the hardware that is embedded in binary into the program memory of this microcontroller. So when we run or when we connect the power supply, it should operate such that when the push button is pressed, the LED will switch on. Else, the LED will be switched off.
Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn